Okay, so like I said, vertex form is the one, or 6.7 is the one lesson where we are going to be looking at something other than standard form. So vertex form of a quadratic is this. It's just another form that a quadratic function can be written in. It is f of x equals a times x minus h squared plus k. In vertex form, and the reason why it's called vertex form, you are able to pull out your vertex right away. Your vertex is the point HK. So H is the X value of your vertex, K is the Y value of your vertex. A note about that H, about your X value. Because in the formula it is X minus H, you leave the minus behind. So I'm going to put a little note to myself up here that says H is opposite sign. So if it was let's use 5 as an example. If it was minus 5 right here, then H would be positive 5. If it was plus 5 right here, it would be minus 5. So your H value is always the opposite sign as what it is in your equation. You can find your y-intercept of your quadratic by plugging in 0 for x. So that's the same thing we did in standard form when we plugged in 0 for x. It's just going to be a couple more steps this time, but we'll be able to do it all in our calculator. Okay. And then the last thing is our parabolas today. They can open up. So opening up would look like this. Or they can open down like this. They are going to open up if A is positive, and they will open down if A is negative. So at the beginning of the problem, you should be able to see whether it's going to open up. So like this one right here will open up. This one will open down. Okay. So today when we are making our graphs, when we graph standard form, we graph 5 points. Today we are only graphing 3 points. We are going to identify and graph our vertex. Then we are going to find our y-intercept, and then we're going to do the same reflecting of our y-intercept across our axis of symmetry. So our first step is to identify and graph our vertex h comma k, and to draw our axis of symmetry when we do that. So moving down to our first problem here, this is my h value, this is my k value. So my h value is 2, so that's my x value of my vertex, and it is positive because h is always the opposite of what it is in the quadratic. And then my k value is negative 3. So the h is the opposite sign, k is the same sign as it is in the equation. From there, we can go ahead and graph that ordered pair. So we can graph an ordered pair at 2, negative 3. I went right 2, down 3. When I graph my vertex, I also want to draw an axis of symmetry. So I'm just going to draw a dotted line that goes through that. Okay. And then from there, we are ready to find our y-intercept. So we are going to plug in 0 for x. So instead of 2 times x minus 2 squared minus 3. We're going to replace that 0 right there with, or replace that x right there with the 0. So it'll look like this. 2 times 0 minus 2 in parentheses squared minus 3. If you don't already have your calculator, go grab it. You're going to need your calculator for every day for the rest of this unit. Okay, and then you are going to plug this in. So it's going to be 2 open parentheses. Inside your parentheses, you're going to put 0 minus 2. You have to do minus 2, not negative 2. If you do 0, negative 2, it's going to multiply together 0 times negative 2. 0 minus 2 squared minus 3. Let me come figure out what the error is. Okay, what'd you guys get? 5. I haven't hit enter yet. I agree. Okay, so our y-intercept is 5. Any questions about finding that?
How did x become 0?
So x, the reason why we're plugging in 0 for x is we're looking for the point that is on the y-axis. And whatever point is on the y-axis will have an x value of 0. So we're choosing to plug in 0 because that'll give us a point that's on the y-axis. So this is the point 0, 5. The x value is 0, the y value is 5. And we can go ahead and graph that on our on our y-axis at 5. So you go ahead and graph your y-intercept. Okay, and then our very last step is to reflect the y-intercept to the other side of the axis of symmetry. We did this back in 6.4. You have to reflect it across the axis of symmetry. So that's the dashed line that we drew. So we were 2 points to the left. We're going to go 2 points to the right. Put a dot there. Okay, today you're going to get 3 points, and then you're going to connect them. Connect them into a U shape. Don't draw a straight line into a V shape. Connect it into a U shape. Thank you. Grab a note sheet, please. Okay, something that you guys can notice on this one, my A value here too was positive. This opened up. The next one, -4, that's negative. So this one's good. The next one's going to open down. You guys will see that when we graph it. Any questions right now? Okay, we've got one more on this side, and then we have one on the other side that's slightly different. It is the reason why I have that one on the other side. There's not going to be one like it on your assignment, but there is an extra credit assignment up here that does have some like it, so I wanted to show it to you as well. So we've got -4 times x plus 1 squared plus 2. First thing that we are going to do is find our vertex, which is our h and our k value. So in this one, because this is +1, my h value is -1, because my h value is always the opposite. And then my k value has the same sign. It is 2. So So my vertex is -1, 2. I can go ahead and graph that. So I start at 0, 0. I will go left 1, up 2. When I graph my vertex, I also want to graph my axis of symmetry. I'm going to draw a dashed line through there. Okay. And then we are ready to find our y-intercept. So to plug in, or to find our y-intercept, we are going to plug in 0 for x. That's going to be -4 times, in parentheses, 0 plus 1 squared plus 2. If you ever choose to do this without a calculator, reminder, you need to do what's in your parentheses first, then your exponents, then your multiplication, and then your addition. Just order of operations. That's a lot of things to keep straight. That's why I do it in a calculator. But just a reminder. So I'm going to put -4 in parentheses. I will have 0 plus 1 squared. And then after that, I will have a plus 2. And I get a y-intercept of -2. Okay. Any questions on finding that y-intercept? I just plugged it in a calculator. Okay, so then we can graph it. So we're going to graph a y-intercept at -2 down here. I put this as a reminder to you of what your last thing you need to do is. You need to reflect your y-intercept. So that y-intercept is 1 to the right of my dashed line, so I need a graph point 1 to the left. Remember, this one's going to open down. So we'll connect this. It'll be a tall, skinny U that opens down. Hey, any questions right now? Hey, go ahead and flip this over. The 2 examples that you've seen, that's what you're going to use on your notes, or sorry, on your assignment. These are your notes. That's what you're going to use on your assignment. Flip this over. There's one more example on the back that is going to become helpful if you choose to do the extra assignment we have up here for extra credit. Some of us need it at this point of the semester. So we've got f of x equals 3x squared minus 2. We do not have any parentheses in this problem. This problem is like technically in vertex form, but also technically in standard form. But we can graph it how we graphed the problems in vertex form. I'm going to take this 3x squared, and I'm going to add in my parentheses. I'm going to put x minus 0 here. So what this means is that my h value was 0, and so that's why there's not a number in there. If we had x minus 0 is just x. So that means my vertex is 0, -2. Which is going to get graphed down here at 0, -2. My vertex in this problem is my y-intercept. So because of that, I can't use my y-intercept as another point because I've already used my y-intercept. So my vertex is on my y-axis. I'm going to go ahead and draw my axis of symmetry through my y-axis. I am going to need to find one more point in order to be able to graph this, and then I can reflect that point to keep things symmetrical. So how we find another point on a graph is we can just plug in any number we want for x. So I've got this 3x squared minus 2. I think I am going to plug in 1 because I know 1's going to fit on my graph. So I'm going to do 3 times 1 squared minus 2. So I'm plugging in x equals 1. And I can do that in a calculator if I want. 3 times 1 squared minus 2. And I get a y value of 1 as well. So that means I have a point at the point 1, 1. So I come over here to 1, 1 and graph a point there. And then in this one, we're going to reflect that new point across my axis of symmetry. So that is 1 to the right. We'll go 1 to the left. And it makes sense that this one opens up because it has a positive a value. There's a little point here, or there's a little line here to write our y-intercept. Our y-intercept was our vertex, so our y-intercept was at negative 2. We already reflected that. Okay. Do not worry about this problem on the back until you get to the extra credit assignment. So when you glue in your notes, don't glue them in so that this is on the front. Glue them in so that this is on the front, because these are the examples we want you to use when you are doing your assignment. Okay, I'm going to go ahead and stop this video. Bye, video.